The year is 1980. An exploration company called West Australian Petroleum is prospecting for gas off the northwest coast of Australia. What it discovers will start a chain of events, leading to one of the most ambitious gas projects ever undertaken.
The Gorgon Prospect was in 300 metres of water with a target depth of around 4,500 metres, about 60 kilometres to the west of Barrow Island, which was actually a remote location in those days. As a well site geologist assigned to the Southern Cross for the drilling of the Gorgon exploration well, I've been able to see it about 6 to 7 days on that rig.
Perth is asking by radio, are we there yet? Are we there yet? Yeah, they're waiting and they know which day it's going to come in.
When the drill bit went from the siltstones and shales into the gas sands, the gas detectors went crazy.
The hum starts.
We're going to cut a core and we're going to see what's down there. As a well site geologist, to see the gas detector going crazy, not for 5 or 10 or 15 metres, but for 50, 60, 70 metres, that was something inspiring.
They have a sense of destiny in a funny way. It's kind of like you feel like you're onto something big here, because this was the big one we were chasing. We knew it was a giant.
We went from a prospect mapped in the subsurface at around 4,000 metres of 30 square kilometres to something that was in excess of 300 square kilometres. That's world class, that's a supergiant gas field of the day.
Though Gorgon was a giant gas field, could it become a commercially viable project?
To make an LNG project commercially viable, you need a market. We had to wait for markets to develop in Korea, China, for their economies to grow enough. So it was a long-term project. The things that drive the cost of the LNG you sell into that market are really the cost of producing the gas, the cost of processing the gas, turning the gas into a liquid. And then the third thing is related to shipping. And obviously the further away you are from market, the more it costs to ship it.
Gorgon's gas had another feature that affected development plans.
We realised we had a high content of carbon dioxide in the field. We had to deal with the CO2. The partners decided early on that we weren't going to vent the CO2.
In the late 1990s, studies were done to look at potential options for geological storage for the CO2, and a number of sites were looked at. You need to have a rock area that's thick enough and large enough with enough pore space that can actually store the volume of CO2. And the other thing that we need to have is we need to make sure that above the injection interval is an impermeable layer, what we call a seal. And the geology of Barrow Island was an area that kept coming up as looking like the best place to do it.
So Barrow was chosen as our preferred option because it was the nearest hub that you could produce subsea directly back to a hub location onshore. In addition to that, it provided the opportunity for us to sequester CO2 on the location that we removed it from the gas.
In October 2000, Chevron and Texaco announced their merger. The newly formed company now owned a majority share of Gorgon and assumed the leadership role in developing the project.
Well, I think the concept of having a LNG plant on Barrow Island, can be quite challenging. Barrow Island is a Class A nature reserve, and it's designated to really protect the flora and fauna that's here, because we've got some fauna here that is extinct on the mainland or is severely restricted there, but here it's intact.
To allow a large industrial development on a Class A nature reserve is not a small issue.
In early 2000, the exploration and production managed by West Australian Petroleum was assumed by Chevron. This included Australia's largest onshore oil operation, which had been based on Barrow Island since 1964.
The quarantine began very early. One of the first recommendations I made since 1964, as well as not losing any species, we haven't introduced any species either. Or with management, you can have conservation and development. You can have the two things successfully.
And we were very successful in keeping off invasive weeds, rats and mice and cats and all those sorts of things. But it was recognised very early on that we needed to upscale that substantially.
Offshore, another giant gas field joined the Gorgon Project.
The Janssio field is a world-class gas reserve. And if you're going to make an investment of the magnitude that Gorgon is, you need to know you have a very secure gas supply, a big enough resource base to keep that plant running for 50 years.
We had plenty of gas. It looked like we needed to add a third train in order to make the overall development economic. It's a Class A nature reserve, and actually the marine environment offshore is also a protected environment. So learning the rules and then designing the plan around the rules was very important.
For the Gorgon Project to progress any further, an Act of Parliament needed to be passed by the state legislature.
Barrow Island looks more like a Texas oil field than an A-class reserve. Controversially, the government has given in-principle support for a $6 billion gas processing plant to be built on it.
The Barrow Island Act really gave legitimacy to the project in the state's eyes, and it had bipartisan support from both sides of Parliament.
Because Barrow's a Class A nature reserve, the government was very keen, and quite rightly so, that we should contain our footprint to the smallest amount reasonably feasible. One of the things the state agreement did was limit our footprint to this 300 hectares.
We had 300 hectares, including all the right-of-ways for the pipeline, road expansion, the plant, the camp, 300 hectares. Normal plants are 10 times that.
In 2009, the Gorgon joint venture participants settled on a plan.
Monday, 14th of September, is a date that I will remember. We had a lot of documents to sign, granting of leases, approvals documents, that all had to be done in about a 4-hour period before the official press statement.
On behalf of the Gorgon joint venture, Chevron, ExxonMobil, and Shell, I take great pride in being able to submit to you today the readiness letters for the Gorgon LNG development for your signature and endorsement.
This morning, the Gorgon joint venturers made their final investment decision to proceed with the Gorgon gas project. And that decision has been taken with the joint venture partners accepting and agreeing to all conditions laid down by both the state and the Commonwealth governments.
Gorgon redefines what technically complex, environmentally responsible projects will look like. To remind you, Gorgon will have 3 5 million ton per annum LNG processing trains, the world's largest carbon dioxide injection project, and a domestic gas plant. Gorgon is a giant. The 40-year project will produce about 15 million tons of liquefied natural gas every year.
This project secures Australia's position as an energy superpower and a world-class supplier of LNG.
If we rewind back to 2008, start of the global financial crisis, by 2009, governments really understood what the benefit of Gorgon was going to be.
The government recognises this is a very significant day for Australia. This is the largest energy project ever undertaken in this country. It is a project not just of Western Australian significance, it is a project of national significance.
The infrastructure that existed on Gorgon before we arrived was pretty minimal.
We were actually building this particular harbour at the same time as the camp was being built, and we were commencing civils.
We've had to build beds, build temporary infrastructure that allowed us to build our permanent infrastructure that then allowed us to begin to execute the project.
We needed a workforce of 3,000, 5,000. We ended up with close to 8,000 people as our workforce here.
Each one of those workers needed accommodating. Most would stay at Butler Park, the project's construction village.
We have accommodations that are actually built to withstand Category 5 cyclone wind speeds. What makes them an actual safe haven or a shelter-in-place location is the ability to walk in from one cluster into another cluster without having to go outside.
Building new infrastructure requires materials. Supplies sent to this site underwent a stringent quarantine process.
And what that really means is that any piece of equipment had to be checked and rechecked many, many times.
What the quarantine management system for Barrow Island is doing is demonstrating on a small scale that it is possible to prevent the introduction of a non-native species. And the two biggest contributors to the loss of biodiversity is the loss of habitat and the introduction of non-native species. What is unique to the Gorgon program is that we identified all the possible ways in which a contaminant, a non-indigenous species, could make it to Barrow Island. All the possible introductory pathways. We analyzed them, we risk assessed them, and we came up with all these barriers that we have to do. This is possibly the most comprehensive surveillance program ever implemented in Australia.
One of the key places Gorgon's quarantine system operates is at the project's port, the marine offloading facility.
Every piece of equipment and material has to come by water, essentially.
Marine offloading facility, we call the MOF, is basically the main artery for the supply chain. We started with constructing a platform, which was approximately 2 kilometers from the shoreline. So basically, we're trying to build an island offshore from scratch. So the first step was to construct this channel. Using the dredge spoils, we built up the MOF platform itself out of the water.
Building facilities on and around Barrow Island was not without hazards.
The weather is a huge hazard, cyclones being the ultimate hazard. Every time we had a cyclone, we had to demobilize this equipment, get it to its safe haven, get the people off of those vessels, get them to a safe location.
The MOF has enabled modules and pre-assembled racks to be brought onto Barrow Island, more than 270,000 tonnes worth.
Our laydown space was so limited, it is very important to do as much work as possible off-site before you bring it here to hook it up. We've probably put in over 50 million man-hours of construction in modules off-site.
When we bring materials to the island, obviously we're constrained on space, so we have to take advantage of building it onshore first, building it in a storage area off the island.
America, we had Europe, Asia, and Australasia were the primary points where this equipment came from. The supply bases were very, very necessary. Not everything could be stored on the island.
Building the plant in modules is not unique to Gorgon, but the size of the modules is. We've built some of the largest modules designed for an onshore plant and brought them in individually and in just the right order.
They are particularly difficult to move. The centre of gravity, it's very much higher than the rest of the boat, and so those dynamic forces are the ones that really do test a naval architect for a plan. On the island, the tidal range is also important. Because of the size of these modules, we couldn't land them on a 24/7 basis. We had to wait for the correct tide so that the ramp angles were right there.
After reaching the plant site, the modules are then hooked up.
On Gorgon, we have about 9,500 single weld hookups that we have to achieve. And that is actually placing one piece of pipe to another piece of pipe and being able to make that weld without having to rework that interconnection. That's something that's never been done in the industry before. One of our major concerns was how well were we going to be able to bring in these modules that are up to 6,500 tons and up to 85 meters long and 43 meters wide, how we would be able to bring them in on their location in such a precise manner that we were able to make these welds. It's been a massive success, one of the biggest successes on the project.
Offshore lies one of the world's largest subsea gathering systems.
There's 18 wells in total, so the drilling groups were out there drilling the wells that go down into the reservoir, and actually it let us recover the gas from the fields. And they actually mount a thing we called a Christmas tree on top of it. And that's a series of valves, and it's through that that we actually control the flow from the reservoir.
A series of flow control instruments that start at the wellhead in the tree, go through the individual flow lines of the wells and to a manifold where the gas is commingled from all the different well sites, like a junction box.
The structures that we've got for Gorgon and Jansz are different from other past projects. These structures are much bigger. We're lifting 1,000-ton structures down to 1,300 metres. A lot of cranes nowadays don't have the capacity to lift 1,000 tonnes, let alone to lift it all the way down to the seabed. So we've had to develop a new deep water lowering system to actually enable that to happen safely.
We factor safety into everything because everything out here is big, it's unforgiving, and there's always risks with everything that we do. All the equipment that we handle is big and it's heavy, so we have to be careful.
What makes the pipeline system unusual for Gorgon was the size and the distances, as well as the complexity of going over the deep water to shallow water escarpment.
The escarpment, it's very simply, it's like an underwater cliff. The question for us as a subsea group is how are we ever going to thread a pipeline out to where these drill centres are going to be. Normally pipelines, we don't like spans in our pipelines. So to actually design one in has made the Jansz pipeline fairly unique. We actually designed a trench, a notch in the top of the escarpment, and that let the pipeline hang in a very nice curve as it went over the escarpment.
So a typical free span might be 2 or 3 meters. In the course of the Gorgon super span, it was 300 meters. The span associated with the escarpment was something that I had never come across in my experience.
These vessels are the largest in the world and deploying some of the largest pipelines in the deepest oceans in the world.
They join a pipe 12, 13 meters long. They weigh upwards of 10 tons. Handling each piece of pipe offshore of this size, this weight, is a very delicate operation.
Those joints get put into the firing line. So in that firing line, we line up the joints of pipe, we weld them together, we inspect them, and then gradually lower them off the back of the vessel.
A spool is basically an interconnecting piece of pipe between the wellhead and the manifolds. These are the last pieces of the puzzle that we had to install to ensure that we had a complete pipeline system from the well to Barrow Island.
The Gorgon team deployed an unusual drilling technique to bring the pipelines ashore onto Barrow Island.
The drill rig we had at North Whites Beach, there was actually 2 of them, is designed to drill sideways. By using the horizontal directional drilling technique, we were able to limit our impact on the island. We were able to retain the natural features of the site. The umbilicals for both Gorgon and Jansz IO are the lifeline that allows us to operate the subsea equipment. Back behind the sand dunes at the beach, there's actually a termination point where those umbilicals are anchored and tied off. And then from there back to the LNG plant, we have bundles of hydraulics and separate power and fibre optic.
Across the LNG plant site, a number of work fronts opened up.
We have 2 tanks and they each have a capacity of 180,000 metres cubed. We started off with the civil works. From the concrete we moved on to the steel work, the tank floor and walls made out of carbon steel. We also started building the roof. Then we raised the roof, so that was called the air raise, where we used air pumped into the tank and use that volume to lift the roof up to the top of the tank.
The tanks store the liquefied gas before it's loaded onto LNG carriers.
You have to build the jetty so that eventually the LNG carriers can come in.
In total, there's 56 caissons out there. Each one weighs 3,000 tonnes each. They provide just a solid weight, a solid foundation for the pipe racks and the roadways to be installed on. We've got 48 pipe racks going out that transport the fluids, and 250 kilometres of cabling all the way out that provide power and controls to the LNG loading system. The loading arms are the last bit that connect the actual LNG piping to the tanker.
The 2.1 kilometre jetty also enables the export of domestic gas.
The domestic gas, we thought, was going to be a much more conventional type pipeline. It was a smaller diameter pipe, only 20 inch, a much thinner wall. It was in shallower water. All we really had to do was get it over to the mainland and lay it across the mainland. The bit that really made it a challenge was actually when we crossed the mainland. Where we come on shore is a place what we call the intertidal zone, which is a region up to about 12 kilometres long where it's not really wet, but it's not really dry. Our contractors dug a trench, like a channel, from the mainland out through the intertidal zone, and we floated the pipe out and we joined the strings together.
Once construction is completed, commissioning can begin.
This is the point of the project that attention to detail becomes critical. Every detail of each piece of equipment needs to be functioning correctly. All of our processes and procedures need to be perfect and in place.
The Permanent Operations Facility, or sometimes affectionately known as the POF, is the daytime home of operations, and that provides remote monitoring and control of the entire LNG facility and subsea infrastructure. In the control room, we have probably over 150,000 bits of information coming in on temperatures, pressures, valve status, compressor and motor status that the operators actually look at and monitor and use for control of the facility.
So we have the monitoring system, the hydraulic pumps are here that send the hydraulic pressure out to open the valves 160 kilometers away. And yes, it was very satisfying when we opened the valves, we got the gas flowing, it pressured up the pipeline, all did it very safe manner and controlled manner.
It's a good feeling, a good sense of accomplishment of all those years, sort of seeing it finally, coming to a culmination.
With infrastructure in place and powered up, the plant is now producing liquefied natural gas.
Gorgon Project is much more than a gas plant. We have major utilities here. We have desalination plant, we have the construction village or Butler Park.
Yes, there are facilities that have glycol plants. This is the largest glycol plant in the world. I mean, you talk about a 2-kilometer causeway with a 2-kilometer gravity-based structure that sits on top of that as a jetty.
The Gorgon CO2 project is the world's largest storage-focused CO2 injection project.
The Gorgon project is different from other projects in the fact it's the size and the magnitude of what we're trying to do. We are pushing technology across the board, not only in the design phase, but also in the installation phase too.
We've built this legacy that's going to go on in the industry for many years to come.
I think the biggest impact on me was it gave me my first taste of field work in Australia. It was only when I really stepped foot on site, really got a feel for, wow, this project is big.
Gorgon is a legacy project, and projects the size of Gorgon, it takes a lot of people working together to deliver a project this size. It takes an incredible amount of teamwork. The Gorgon project is truly a multi-generational project. It's one of the largest engineering and logistical efforts ever undertaken in Australia's history. And it will continue to pay economic benefits, provide job opportunities, as well as energy security here in Australia. The global energy demand is increasing, and it's increasing even on a greater rate in the Asia-Pacific region. And Gorgon is well placed to meet that growing demand through the ability to provide a cleaner burning energy supply for decades to come.